This is a production of Cornell University.
Dungate from Bioenergy and recently installed this huge boiler at Cornell Agricultural Research Station here to burn willow chips. I'm going to introduce you to the main features of the boiler. It's going to heat the complex here using the willow chips. So this boiler was manufactured at our plant in Schenectady, New York. It's based on a European design, but it's been Americanized to meet the ASME standards. And the key features of this boiler are the level of automation that allows us to achieve high efficiency and very low emissions compared with other boilers that are currently available in the US. How we achieve that good efficiency is firstly by the fuel. We like very dry fuel that's a consistent size. And when we say dry, we mean about 30% moisture or below. So that doesn't have to be mechanically dried, but just air dried. And the reason we like dry fuel is because otherwise you're cooking off moisture and you're spending a lot of energy just to dry the fuel before you can start to get heat out of the fuel. Secondly, when you're drying that fuel when it's wet, you have a very cold, inefficient burn, and that tends to create more tars and creosote emissions. So by burning a dry fuel, that's a very important way to get the high efficiency clean emissions. On this side here, we've got our feeding in from the chip storage. That's automatically fed. We have an intermediate fuel bin here with an ultrasonic sensor that measures the depth of fuel in this bin. When the fuel level drops, it's automatically refilled by the auger running. I'm going to take off this cover here and show you inside. We've got a series of 3 independently controlled fans, 1, 2, 3, that have deliver air in different zones, both underneath and from the sides inside the combustion chamber. We measure the oxygen level on the output. We measure the pressure inside the combustion chamber. We're constantly adjusting the fan speed and the exhaust fan speed to keep the boiler balanced and keep the combustion very efficient. The fuel's fed underneath to the combustion chamber and comes up through the center of a round grate. That fuel is dosed and the fan's balanced automatically. When the boiler reaches temperature, it reduces that feeding rate and slows down just to maintain optimal conditions. If we open the door here, we can see inside. I don't have my glove, but we'll use a 2x4 to open it up. You can take a look inside and see the nice flame. It's very, this chip size is a little bit larger than usual. We're getting quite a buoyant flame. Well, you can see there, it's a very clean burn. We don't see any black tars or creosotes, and also up the stack you'll notice that it's very clean. We control the pressure inside, so if I open this door, the fan speed automatically starts to speed up to try and maintain the air pressure, but have to keep it closed to keep that optimal burning condition there. Once the fuel is burnt, the ash gets to the side of the combustion of the burning grate. Augers automatically remove the ash to the ash collection bin right here. We've just been firing for a couple days, so we won't see any ash yet. It will probably take a couple weeks till we even start to see any ash in that bin. And that's because the chips are fairly clean, but also the ash has to fill up the cavities inside the auger channel, which are removing the ash before it actually can start to push the ash out. Those are the main features of emissions and efficiency. The other key thing is the safety. We've got automatic systems to control pressure, over temperature, which are standard for any boiler. And also for wood boiler, we've got special sensors that keep the solid fuel contained and enclosed and would smother any burn back that happened. I think this is a really exciting project here at Cornell, that we're excited to be burning willow chips, which we see as a fuel that can be grown on agricultural land economically, and is just a great fuel for our boiler.
This has been a production of Cornell University, on the web at cornell.edu.